All right, I'm back. This is Unit 5. This is chapter review. We're on number 14 here. So we're going to determine the length of line segment KL or side KL in the trapezoid shown. Okay, so what we're going to do in this problem is that you notice that we have this line segment here, H to I, which connects H, which is a midpoint as indicated by these congruent marks right here, and it connects another midpoint I as indicated by these double marks here, which show that those two pieces are congruent. So that is called a mid-segment. Okay, so the rule is that the mid-segment, which is represented as 5x plus 2, is going to be equal to the sum of the two bases of this trapezoid. Okay, so this base and this base, we're going to add those two up. So we're going to take 4x plus 1, and then we're going to add it to 27. And then the rule is the mid-segment, if you take the sum of the two bases and divide it by 2, those two values will be equal or equivalent to one another. Alrighty, so hang on 1 second. I'm walking away. Alright, there we go. Sorry, I had to adjust the lights in the classroom so you could see a little bit better. Okay, so what's the rule or property that we're used to solve for x? We're using the fact that the mid-segment of a trapezoid is equal to the sum of the bases divided by 2. Okay, so that's the idea that we're going to use. So then we're going to solve this equation. So when you solve it, the first thing you want to do is you want to combine like terms with the numerator over here. So you're going to combine the plus 1 and the plus 27, and that would make my equation 5x plus 2 is equal to 4x plus 28 divided by 2. All right, that's what that would become. Then, as we've talked about in previous problems, since we're dividing by 2, if 2 divides into both of these values, the 4x and the 28, and it divides in evenly, then go ahead and divide. It's your best bet. So notice 2 goes into 4x, that would make that 2x. 2 goes into 28, that would make that 14. So, simplifying the problem, I get 5x plus 2 is equal to 2x plus 14. And I'm going to continue to solve this equation for x. So I'm going to subtract 2 from both sides. And at the same time, I'm going to subtract 2 x's from both sides. Okay, so I'm just doing 2 steps in one to cancel out the 2 x's and cancel out the 2 x's. And you can see that my equation becomes 3x, 5x minus 2x is 3x, is equal to 12. I divide both sides by 3, and I get x to be equal to 4. Okay, now I'm going to put that answer in the clouds because that's not my answer, but I do need to know the idea that x equals 4. So don't fall for the trick that you would say the answer is B in this problem. Notice you got to go back and make sure you know what the problem is asking you to find. That problem is wanting you to determine the length of line segment KL. Okay, KL is not 4, x is 4. But how do I find KL? Well, that's where I'm going to substitute 4 in the place of x. So KL would become 4 times 4 plus 1, which is 16 plus 1, 17. So the answer to number 14 is D. Okay, number 15, if the measure of angle A is equal to 80 degrees, all right, so we're going to mark angle A as being equal to 80 degrees. We want to find the measure of angle B, angle C, and angle D, and then part B, we want to say what type of quadrilateral is ABCD, and we want to be as specific as possible. Okay, so if you notice, we have 2 sides that are parallel to each other. So in this problem, we have a 4-sided shape. So that makes the shape a quadrilateral, but we have only one pair of parallel sides. So that's going to ensure that we have a trapezoid. Okay, so this is a trapezoid, but if you notice, we have this part of the trapezoid, the 2 non-parallel sides are both 6. So that non-parallel side is equal to that non-parallel side. So that answers our question for B. This tells me this is an isosceles trapezoid. Okay, whenever you see the word isosceles before the name of a shape, that means it has two equal sides. Okay, so what does that mean? And I remember an isosceles trapezoid, the two base angles are the same measurement. So if angle A is 80, angle D has to be 80 degrees as well. All right, and then the two top base angles, B and C, will be the same. And then the other rule is that the consecutive base angles, these two angles here, an angle on the top that's consecutive with the angle on the bottom, those have to be supplementary. So that means angle B has to be 100 degrees. These two have to add to 180. And that is equal to that, so there we go. So angle B would be 100, angle C would be 100, angle D would be 80, and this is an isosceles trapezoid. Okay? Number 17 says ABCD is an isosceles trapezoid with mid-segment EF. We're going to determine the following. So we need to find the value of N. We need to find the value or the length of E to F. We can't do that till we know N. We need to find the value of X. And then we need to find the measure of angle ADC, and we can't find that angle until we know what X is. Then we have to state the rule or the property used for solving. Okay, so let's go ahead and find N first. Notice it tells us that E to F is a mid-segment. Okay, so we're going to use the mid-segment rule. Okay, so the rule or the property that we're going to use for N is we are going to use the mid-segment rule. And the mid-segment rule, or the mid-segment property, would probably be the more accurate way to say it, is that the length of the mid-segment, which is 3n minus 4, is equal to the sum of the two bases, which are 10 and 36. So you add the two bases of the trapezoid up and you divide it by 2, and that's equal to the mid-segment. Okay, so that would give me this equation right here. So now let's work it out. 10 plus 36 is 46. 46 divided by 2 is 23. So my equation would become 3n minus 4 is equal to 23. And now I'm going to use algebra to solve for the value of n. Add 4 to both sides. 3n is equal to 27. Divide by 3. N is equal to 9. Okay, so that would be my answer for n. Now, the next part, now that we know n, we could find the length of E to F. E to F is represented by 3 times n. N is 9, so we substitute a 9 in the place of n. So that becomes 3 times 9, 27, minus 4, so E to F is 23. Okay, so there we go. Now let's find the value of x. All right, so if you notice, x, we have a 2x minus 17, this expression here with the degrees, so it's telling us that this angle right here, which is angle A, is represented by 2x minus 17. And then we have another angle up here, 3x plus 2 degrees, so it's saying that that angle right there, which would be angle B, is represented by 3x plus 2. Okay, so what's the rule between a base angle on the top and a consecutive base angle on the bottom? Remember, the rule is, in a trapezoid, those two angles are supplementary. So what does that mean? It means that the equation that I'm going to create to solve for x would be 3x plus 2 plus 2x minus 17 is going to be equal to 180 degrees. And the property that I'm using to solve for x is consecutive base angles in a trapezoid are supplementary. Okay, and then once I have my equation set up, I'm going to use algebra to solve for x. Alright, so I'm going to combine the 3x with the 2x to make 5x. I'm going to combine the positive 2 with the minus 17 to make minus or negative 15. That's going to be equal to 180, and I continue to solve. Add 15 to both sides. That gives me an equation of 5x equals 195. Divide both sides by 5. X would be equal to 39. So there's my value for x. Okay, the last part says find the measure of angle ADC. So let's find out where that is in my diagram. So start at A, go along the shape to D, take a turn for C, and right where you make the turn, it's that angle right there. So that's the angle we want to find. Okay, well, how are we going to find that? So remember, since this trapezoid is an isosceles trapezoid, it means that however much that angle is right there is going to be congruent to the measure of the angle I want to find, measure of angle ADC. So I'm going to take the value of x, which is 39, and I'm going to substitute it into this equation. So this angle would become 2 times 39, that is 78, minus 17, so that's 61 degrees. So that means that angle ADC is 61 degrees as well. All right, moving on to the next problem here. So the next problem I want to take a look at is number 19. Number 19 says that, let me get to it. There we go. There's number 19. It says ABCD is a rhombus. Determine the following: X, Y, N, and Z. There's X, there's Y, there's N, and there's Z. And then we're going to state the property that we're going to use to solve for Y and N. Okay, well, let's find Y first. So the first thing that we notice is that, remember, in a rhombus, and this shape is a rhombus, one of the properties that we learned was that the two diagonals, B to D and A to C, right where they intersect, they're perpendicular. So that means all of these angles here, right in the middle of the rhombus, where the two diagonals intersect, are 90 degrees. So that gives us our answer for Y. So Y is going to be 90 degrees. Okay, now what property did I use for that? I used the fact that diagonals are perpendicular in a rhombus. Okay, diagonals are perpendicular. That's the property that I used for a rhombus. Okay, so now that we know that that angle is 90 right there, and notice we know that this angle is 43, so remember in a rhombus that the diagonals bisect each opposite angle into equal angles. So if that's 43, it means that that angle right there is 43, which means that these angles here are all 43 as well. So that means the value of Z is going to be 43 degrees. All right, so now once I have the value of Z, what you want to do to find the value of X is you want to focus in on the triangle that I'm outlining in green right here. And the reason why I'm going to focus in on that particular triangle is because, two reasons. One, because X is in that triangle, and secondly, if you notice in that triangle, I know that angle is 90 and that angle is 43. So that means that if I know two angles of a triangle, to find the third angle, to find X, all I would have to do is add up the 90 and the 43, and that would become 133, and then I would subtract 133 from 180, because the three angles in a triangle add up to 180, so that means X is going to be 47 degrees. Okay, now let's find N. The last part we want to find is N. And now, if you notice, N is, I have a 15N minus 7 expression here, and that represents side A to D. And then I have a 12N plus 20 expression here, and that represents side C to D. And once again, this shape is a rhombus. So if it's a rhombus, all four sides are equal to one another. So that means the equation that I'm going to use to solve for N would be the 15N minus 7 side. I would set it equal to the 12N plus 20 side. Okay, and the property or the rule that I'm going to use to solve for N is that all four sides are congruent in a rhombus. Okay, and then I'm going to solve this out. So I'm going to subtract 12N from both sides of the equation. That would, after those 12 n's cancel out, I would get 3n minus 7 is equal to 20. I'm going to add 7 to both sides of the equation. After the 7's cancel out, my equation would be 3n is equal to 27. Dividing both sides by 3, n is equal to 9. Okay, so there we go. There's number 19. Okay, number 20, what we wanted to do in number 20 was, I did not want you to worry about the midpoint parts. I just wanted you to find the coordinates of Q, okay, without using any new variables. Okay, so we're going to find the coordinate of point Q, which is right here. Now if you notice that to get to point Q, it's the same distance from the origin as point R. And point R, that C value tells me how far I moved over, so that's C. So point Q has an X value of C. And then I'm going to go up to get to point Q, and if you notice, the height of Q in this graph is the same as the height of P, and that height is represented by K. So the coordinates to point Q would be C, K. Okay, we're going to do the same thing for number 21. We are told that 21 is a parallel. Actually, you know what? We're not going to do 21. Just wanted you to do number 20. I'm not worried about parallelograms in this case. Okay, turning it over, I asked you to do number 22A. So in 22, it said plot the points A, B, and C. So let's do that first. So A is 1, -1. That's over 1, down 1. That's A. B is over 2, down 4. So there's B right there. And C is over 4, 1, 2, 3, 4, down 2. Okay, so that's C. Now, so we've got A, we've got B, we've got C. And I'm going to zoom this in a little bit so you'll hear a little sound as I zoom it in. And now what we're going to do is, I'll zoom it in just a little bit more. There we go. It says plot a fourth point D in quadrant 4. Okay, so we have to plot a fourth point somewhere in this quadrant right here, anywhere in here, that will make a parallelogram. Okay, so the fourth point that you would want to plot would be, it would probably be somewhere in this region over here. Okay, so the way that I do it is, remember, the opposite sides have to be the same length. So I would go, like, notice to get from A to C, we go down 1 over 3. So if we went down 1 over 3 and we put a point right there, would that look right? No, that would not look right. Okay, so but if I went 1, 2, 3, 1 and I put a point right there, that would probably look right from B. Okay, so that's where point D would be. So there is my parallelogram in number 22A. Then we go down to the bottom here, and the instructions say, explain why the quadrilateral formed is a parallelogram using the slope formula. Okay, now it said slope formula. I really don't care if you use the slope formula or if you just use the counting method of counting rise over run. All right, so I'm going to use rise over run, and what we're going to do is we're going to find the slope of all 4 sides of this shape. So first of all, let's find the slope of AB, side AB. Okay, slope of side AB. So if I want to find the slope of AB, remember, start at the lower point on the graph, which is B, and go straight up until you're even with A. You can see you go up 1, 2, 3 units, and then you move left 1 unit. So my rise is 1, 2, 3. My run is left 1, so that's -1. So my slope of side AB is 3 over -1. And you could reduce that or simplify that to -3, but I'm just going to leave it because I want to compare it to the other side slope, which would be side DC. So now I'm going to find the slope of side DC. Okay, so DC, D is the lower point. Let's count the rise to get even with C. That'd be 1, 2, 3. The run is -1. So notice my slope is 3 over -1. So notice the slope of A to B and the slope of D to C are the exact same. So that tells me that side AB is parallel to side DC. Okay, and so what I have now is I have 1 pair of parallel sides. Now, does 1 pair of parallel sides explain to me why this quadrilateral is a parallelogram? That answer is no. I need 2 pairs of parallel sides. So that means I have to find the slope of the other 2 sides. So I need to find the slope next of either side BD or AC, it doesn't matter. Let's find the slope of side BD. Start at the lower of the 2 points, which is D, okay, and you will notice that you need to rise up. Where is D at? I think it's right there. So I didn't graph it very well. It's right there. So you would rise up 1, and then you would run 1, 2, 3 to the left. So the slope is 1 over -3. And then I'm going to also find the slope of side AC, and we're going to hope that slope of AC side is going to be the same as the slope of BD side. Okay, so AC, C is the lower point. Let's start there. So you could see that when we rise up 1, and then we run 1, 2, 3 to the left. So I have a 1 rise, a -3 run, 1 over -3. Those two sides have the same slope, so that tells me that side BD is parallel to side AC, and therefore I have 2 pairs of parallel sides. I have just explained why that is a parallelogram. Moving on to number 23. In number 23, we're going to determine whether each statement is always, sometimes, or never. Okay, and what you want to do in number 23 is, and I don't know where my notes are exactly on this, you're going to use the part of your notes where it was the always, sometimes, never part of your notes. There it is, right there. I just found it. So always, sometimes, never part of your notes. I'll zoom it out. So I'm going to be going like this, and back and forth. Don't get dizzy. So the first one, a rectangle is a square. So let's start at rectangle, which was the first shape mentioned. I'm moving the square, so I'm moving down the shape. So remember, so the arrow, here's the down arrow. The answer is sometimes. Okay, the next one, a square is a rhombus. That means the first shape mentioned is a square. Move to rhombus, so I go to my diagram here. Square moves up to rhombus, and you can see there's my up arrow, so that means the answer is always. So a square is a rhombus, the answer is always. Okay, a trapezoid is a parallelogram, so the first shape mentioned is a trapezoid. The second shape mentioned is a parallelogram. I look at my diagram, there's trapezoid. I'm moving across to parallelogram. You can see when I move across, either left to right or right to left, it doesn't matter, the answer is never. Okay, so this diagram is super convenient for when you're doing always, sometimes, or never problems, but when they mention 2 shapes. When you get to the fourth one, we're going to have to do a little bit of thinking because there's only 1 shape mentioned. So it says the diagonals of a parallelogram are perpendicular. So this is the only shape that is mentioned, okay? Parallelogram, so that's where I'm going to start on my chart, but then I have to go through, and for each one of the shapes, starting at parallelogram on down, I have to answer yes or no, are the diagonals perpendicular? Okay? And you have to know the properties. So a parallelogram, are the diagonals perpendicular? All right, well, if you're not sure about this because you just haven't studied the properties enough, you could go back to your notes and let's start with parallelogram. Here's the properties of a parallelogram, okay? I'm got this right from your notes. So, does it mention that the diagonals are perpendicular in any of these properties? The answer is no, so that would be no. How about a rectangle? So now let's look at rectangle. Okay, here's your notes from rectangle. Does it mention that the diagonals are perpendicular? Diagonals are equal to each other. So that's no. So no and no. How about a rhombus? So let's go to the notes on a rhombus. Does it mention in a rhombus the properties specific to a rhombus? Are the diagonals perpendicular? You can see right there. The answer is yes. So this is no, no, yes. And then remember, a square, the answer is always yes. Okay, so if you have some no's and some yeses, the answer is sometimes. Okay, let's go to the next one. The sides of a parallelogram are congruent. Okay, so the sides of a parallelogram. So I'm going to start a parallelogram, and this is kind of a poorly worded one. I'm assuming it means all sides. So I'm assuming when it said sides, it really means all sides of a parallelogram are congruent. Okay, so let's look at our chart right here. We're going to start at parallelogram. Are all the sides congruent? No. In a rectangle, are all the sides congruent? No. In a rhombus, are all the sides congruent? Yes. How about in a square? Yes. So we have no, no, yes, yes. So remember, if you get some no's and some yeses, the answer is sometimes. Okay, turning it over to the last problem on this worksheet, number 24. Let's go ahead and read it. It says Samantha must prove this theorem. If A to B is congruent to D to C, side A to B is congruent to side D to C, so let's mark that. A to B is congruent to side C to D, and side B to C is congruent to side D to A, then ABC is a parallelogram. And here's her proof. She said A to B is congruent to C to D, and B to C is congruent to D to A because of the given information. A to C is congruent to itself, A to C, by the reflexive property, so that's marked that A to C is congruent to itself, okay? It says triangle ABC would be congruent to triangle CDA by the blank theorem. Okay, so which one of those theorems, side, angle, side, angle, side, angle, 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 side, 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 hypotenuse, leg, or corresponding parts of congruent triangles would make the two triangles congruent? Well, if you notice, we have 3 sides that are congruent. So this answer would be D, side, side, side. And that's all you had to do.